and how Hadoop comes out to be the best solution to deal with the big data, and what are the features of the Hadoop, and why is it so that all of a sudden people are talking so much about the big data and Hadoop and all. So uh, uh, let us start with the data. We say that we live in a data age today because everything is getting digitized. As our entire communication is digitized today, we see a lot of e-commerce and all. And this is the reason why we say today we live in a data age, because we give lot of value to that data. And if you just see the size of the digital universe, which is the entire data content in the entire universe, the digital data, it has increased almost 10 times in the last 5 years. And one more fact to this is every day we add almost 2.5 quintillion of the data. So this much of data is getting, and we have a rapid increase, tremendous rise in the volume of the data. So that's the reason why people say we live in a data age today. If we look at the sources of the data globally, we find mobile use of the internet is one of the leading contributor to the big data, followed by the cloud computing and other factors like IP-based communication and the social media and all. Mobile today, with the introduction of the smartphone and all, and the availability of the internet, people chat, they send the images, voice, videos, everything, and also the same case with the social media also. So this data volume is increasing very rapidly nowadays. Some of the examples are the New York Stock Exchange. It generates about 1 terabyte of the data every day. Now this is all the stocks rate, which changes every day, every second almost. So similarly, we have stock exchange in across the world. So the volume of the data is generated, which is stored, it increases. Another example is Facebook adds about half petabyte of the data every day. Similarly, Walmart database contain Walmart database contain more than 2.5 petabytes of the data. These are some of the very famous, mostly widely used. These are the very famous companies which are the leading contributor of the big data. If we, one of the another example would be like the Large Hadron Collider, which is the one experiment which is going on in Geneva to show the Big Bang, to prove the Big Bang theory. It has 150 million sensors. So each sensor produces a lot of data. It continuously produces a lot of data, and after a proper application, the size is expected to be 200 petabyte of the data annually. So we see whatever we do today, we need to store the data, and that data finally leads to a big data problem where the data volume increases to that extent we cannot handle the data. We cannot handle it with our traditional technologies what we have, so it becomes a big data problem. Some of the salient features of the big data is of course the volume and all is there, but if you look the size, it actually increases from, it starts with a terabyte and it goes from petabyte, yottabyte, gigabyte. It increases. This is the volume, and whenever we see data in this range, we say, yeah, this is what we call it the big data problem. Now, some of the sources of the big data is the sensors everywhere, in the cars, in the automobiles, in the industries. Everywhere we find the sensors which continuously transmits the data, and which is stored and monitored properly. So sensors are contributors. All the web servers which produces lot of log. These are some of the major contributors apart with the mobile and all, which produces the big data source. And like we have lots of logs, text, chats, images, video, system logs, which is all these are all non-traditional data types, because earlier we used to have data in form of some format, it was all structured data, but now the data which we get like images, videos and all, those are not structured, those are all unstructured. So big data, one of the silent feature of big data is it also has unstructured data. Now how it helps as an enterprise, what kind of business insights one person can get out of a big data. Some of the example could be like if you have a lot of data of your business, any enterprise can do some insights and find out which reasons should I increase my marketing or the sales effort. We can come to know, okay, from this area we are getting less business, so I need to market more in this area. This is only possible when we analyze whatever our transaction history says about the sales and all. Also, like who are my top paying consumer? Once we maintain our consumer database well and about their transactions, we can analyze who is my top paying consumer and what extra features we can give to retain those consumers. So these are some of the very basic business insights which enterprise can get out of the big data. And from the technology wise also, it is very important that while we go for processing of the big data, any hardware, because we don't know how the size will go. If today we say, okay, 1 petabyte will be enough, and if it goes to gigabyte, then again we need to get on a tier server. That is not at all feasible. So it is very important that the hardware which we get for big data processing, it should be scalable. So we can keep on adding the hardware as soon as the size of the volume of the data increases. So it is very important that the hardware should be scalable. Another thing is distributed parallel processing. We cannot depend on one particular system to process the entire big volume of the data and give us result in 10 days. Rather, it is very important that we should have some technology which will parallelly in different distributed cluster, it will parallelly process the data and give us some output at a very small period of time. So these are some of the features of the big data, and this is one of the graph released by IBM. It's just this is the beginning of the big data problem. We are here, and in the next 2-3 years, the volume is going to be the big data volume is definitely going to it is going to exponentially rise, and the contributor will be sensors in the device followed by the social media, web and all. So we see a rapid rise. All the analysts, they are predicting a rapid rise in the big data sector. Now, why is it so? Some of the facts about is that the annual growth rate is 60% of the total volume of the data which we produce today. It's combination of both structured and the unstructured data. Some more examples would be like social media alone. It generates 600 new blogs in every minute, 600 new blogs, and about 34,000 tweets are sent every minute. If you see the digital universe, it has increased from 2.7 zettabyte to it is expected to grow up to 8 zettabyte by 2015. So, like it is in every almost 14 months or around the universe, total digital universe is almost doubling. It is increasing double-fold. So that's the reason why people predict a rapid rise in the big data in the near future. Well, big data comes with the 4V, which is 4V is for the 4 characteristics of the big data. First V is for the volume, where volume starts with terabytes and goes up to to any limit we can think of. So volume is definitely which is we measure in terms of more than petabytes and all. Apart with the volume, we also have the variety of the data. Now, we don't have only structured or a text format of the data which we used to have earlier. Now, the data is it's of a different variety and also unstructured, like the images and voice and all. So, we say nowadays we get a different variety of the data. And when we have volume and variety, it is also important that the velocity of our system should be very high. So some of the examples say that almost there are a lot of people hitting Google, and that took a lot in 1 second. Almost 150,000 hits is made. API call is made to the Google, Twitter, and all. Similarly, for the credit card industry, lot of transactions per second. So this is the velocity by which the data is increasing. Also, our system should be capable to handle this velocity of the data. And fourth V is for the volume. Like we need to have some business insight, some intelligence to find out what value we get out of the big data. How can we mine the data properly through our technology to get some good valuable business insights out of the big data. So these are 4V of the big data. And now how it helps, mostly we have let us say if we have interaction data which is by the emails and the chat transcripts, and this if you have stored all the chats and all the email, you come to know what is exactly going on, what is the insight of the people, what do people really want out of data. Facebook, they mostly come out with some analytics saying this many people are they like this. Recently in the last World Cup, FIFA World Cup, they said we have so many viewers, so many people like the number of the people in India is second, followed by the US. So people, it actually gives us some insight that okay, we have this many people who likes this thing. This kind of analytics is very easy to find out once you have the volume based upon the likes and based upon the comment and all, also the posts and all. So it is very important that we people have some method to have one analytics done on the data which is stored in the form of emails and the chats. We also have web click streams, which is nothing but the stream which we follow in a website. Once we visit a web page, we select a product and then we move on to different page, and then we again move on to find out some other page and we purchase a product there. So this entire stream, it can be it is logged properly, and it can be analyzed to see why a person is not visiting our website and is not turning out into our consumer, rather he is moving out and getting a product from some other website. So this way people can try to get some business insights to turn their visitors into their consumers. So this things is only possible when we have a lot of data available with us and we analyze it properly. Now from the social media, Facebook and the Twitter, we can know about the opinion of the consumers about their product. Any enterprise, they are very much interested in about the feedback. Also the preference, what do people really need? When people give their comments, they also write their preferences as well. What is their needs and their desire? So this kind of data is, it helps enterprise in many sense. Also we have payment history, usage data, which is all stored from this history, if it is stored for all the employees, the manager can see what is the growth of my employee, who should be given a more benefit and all. Usage history is like in case of telecom also, people keep track like what is the usage of my network, how many calls made from which area, where which part is declining, which part is increasing. So all these kind of this helps us. This big data helps us to engage more in the business. And that's the reason why so many industries are moving towards big data analytics. And in terms of growth also, big data market is estimated to grow 45% annually. The geographic wise, it will be like North America followed by Europe, Japan, China, and then India. So this is the prediction by the tutors. And market forecast, we see a exponential rise in the big data market in the next few years. If you see the today's investment by the companies, almost all the sectors, be it be government, manufacturing, banking, everyone they have already invested in the big data. Already they have done to 25% already they have invested in the big data, and in the next year they have plans to invest more. Well, future key role for the big data will be a lot of things are there, but mostly it will be like risk analysis, pricing model where you predict the price of a particular product by following the trend which it has followed. And also we have claim operations and social media analytics. So mostly more than 50% will be the role of the big data in all this analytics. Well, coming to the technology perspective, the traditional technology which we have for the one which we use since many days, almost 15 to 20 days, is the use of the RDBMS for any kind of data storage and data processing. Mostly, yeah, today we can say almost 40 to 60% of the people, they use RDBMS servers. They put very high-end servers for their RDBMS server, and entire data is stored in the RDBMS, and all the analytics is done on top of that data. But moving to the next 3 years, we see a decline in the use of RDBMS and all, and mostly the use of in-memory database and distributed indexing and distributed parallel processing database. The use is expected to grow. The reason is RDBMS, as long as the data volume is up to terabytes, RDBMS can support it. But once the volume goes beyond the terabyte, it is very difficult for RDBMS servers to really scale up and to give us the result that fast. So that's the reason why people will be moving out to more parallel and distributed processing. That's the reason why we see the change in the trend in the next 3 years. The use of the RDBMS will be coming down, and more we will be using more something which should be scalable and parallel processing kind of architecture. Now let us take one example and find out why Hadoop all of a sudden came out to be the best solution. What happened? Why our traditional system cannot support the big data? If we see the storage capability, storage capacity of the hard drives has increased by tremendous amount. Nowadays, our laptop, it comes with a 1 terabyte of the storage. So storage is increasing massively, but the access speed is not taking up to that pace. So let's take one example. One disk drive in 1990, it has capacity of 1370 MB. But the transfer rate was 4.4 megabytes per second. Now, if we take this value, then the full data could have been read in 5 minutes. Because the volume was less, even though the transfer speed was less, but since the volume was less, so it was possible to read the entire data in 5 minutes. Now, today, 1 terabyte of the disk space is very normal, and the transfer speed today is it's 100 Mbps. 100 Mbps. So if we try to read the entire disk, it will take 2.5 hours to read the entire disk with this speed for only 1 TB. And once we talk about petabyte and zettabyte, then we can imagine how much of time it is going to take. This is about the reading, but the writing is more slower. So this is the reason why we cannot sustain with this. Like we cannot wait for 1 TB of data. Nobody can wait for 2.5 hours when we need to process something in petabytes. So that's the reason why there was a challenge to have something which should be very fast, very accurate in reading very high volume of the data. Now, what could be solution of this problem? The obvious solution which comes out in our mind will be let us not read it from at a time. Let us not depend on one system to read the entire. Let us divide the task into different small drives. So if we have 100 drives and we read from 100 drives parallelly, then we can get the entire result in just 2 minutes. So this is the reason why this is the power of parallel processing. We say if we are reading with one disk, it takes a lot of time. So let us read with n number. It's similarly as one person takes a lot of time to do a work. Let's divide the task into many different people. So this is the entire idea behind the distributed and parallel processing of the big data. Now, there is also some problem associated with the parallel processing. Let us say if we have put our data in 100 different hard drive, and we are trying to read the data, and one of the hardware failed. Now, I cannot proceed further. I cannot proceed further because my important data is lost. So how can we? What is the solution for that problem? One of the common way to avoid data loss is through replication. So the entire data set will be replicated 2-3 times. So even if one of the disk fails, the same content can be read from another healthy disk drive. So this is one of the way to solve the hardware failure. And combination of the data. Now, once we have data divided into many different hard drives, how will I combine the entire data to get the output? This was a challenge, and to have a solution for this, people come up with a solution of MapReduce, which is the key concept of the Hadoop. Mostly, HDFS is the one which solves all the hardware-related problem. HDFS is a Hadoop distributed file system, and MapReduce is it's the technology which is used to read and to aggregate all the how to read like from different source of the hard drive. Once we get the data, how can we accumulate and make sense? Okay, this is my final output. So Hadoop is the one which has these two features, and it solves above two problems. So if you look into the creation history of the Hadoop, it all started at in the 2002 when Joe Petting and Mike Caffarilla, they were working on their own project, which is Nudge. Nudge is it's an open source web search engine. They were working on this, and at that time Hadoop was there. It was not the primary project. It was a sub project of Doe Cutting at that time. They were primarily focusing on the Nudge, which was it's what a web search engine at the time. But in 2003, Google published about GFS and MapReduce paper. GFS is Google file system. So it was almost similar to the way what Hadoop has. So Doe Cutting, he took the idea from the Google, and he tried to use this MapReduce concept in his Nudge at that time to just have a better result of his web search engine, and he got a very good result out of by using the MapReduce concept. And then later he in the year 2006 he dog cutting because this Hadoop at the time it needed a lot of hardware to test. And the Hadoop he joined Yahoo. Yahoo said, okay, I will sponsor your project Hadoop, and you have to come up with some better solution. So he worked with Yahoo for some time, and he was with the help of this map reduce concept, he was able to sort 1 terabyte of the data in 3.5 minutes by just putting 910 nodes. Node is nothing but different parallel system. Each system is a node. So he just put 910 nodes and he was trying to store 1 terabyte of the data. He got a very fast result in 3.5 minutes, which was a remarkable achievement at that time. And later in the year 2009, the same sorting was done in 62 seconds by simply adding the number of the node to 1460. And this is when people realized the power of parallel processing. And later, Dow Cutting rejoined Cloudera, and today he is chairman of Apache, from which this Hadoop is open source project of Apache Group. Now, the international summit of the Hadoop, it also saw a rapid progress after that. After the very good results from the experiments of Yahoo, people they got to know about the Hadoop, what is Hadoop, how can it solve our problem, and the number of people in this summit, it's an exponential rise over there as well. If we see the contribution from the all different companies, almost all the big companies, be it Amazon, Apple, Twitter, Yahoo, Facebook, everyone has contributed in the evolution of Hadoop from all the possible sources. Like this is about lines of the code which all the companies have contributed in getting the Hadoop in place. Well, if you see some of the key features, this it's an open source framework for writing and running distributed application. This is now why is it that people talk so much about the Hadoop? It is accessible because the hardware which is required for running the task of the Hadoop, it's not very high-end system which people cannot afford. It's our traditional system or a commodity machine, the one which we can use our laptop or something, our own desktop as a node. So that's the reason it is very accessible. People can access it. People can have their own cluster and people can work on it. That's the reason it is one of the key features of the Hadoop. Now, second one is it is very robust. The architecture is the entire architecture is defined, keeping in mind that since we are going with a hardware which can fail at any moment of time because it's commodity hardware, it's cheap hardware. So the entire architecture is such that even if hardware fails, there will be no problem, there will be no issues at all. The data processing will be carried on. So, and also it is very scalable. So whenever the data volume, we can scale up just by adding the number of the nodes, or we can decrease just depending upon the amount of data we need to work on. We can scale up or scale down the number of the nodes. So if we don't need required hardware, we can take out those hardware from the cluster and use it for another way. So it is very flexible in terms of scalability and very simple. Like the coding way, it's also very simple and it's very cost effective because the hardware earlier people used to put lot of money on the servers. Today it is very cost effective because the hardware price is very cheap. So it is very affordable. So these are some of the key features of the Hadoop. And why is it so popular is mostly because trend today is to move from a proprietary to a open source. Now this move came after the introduction of the Linux, where after the introduction of the Linux, which is open source, everyone nowadays, every application nowadays we see that turning out to be open source. people don't want to invest money in licensing and all these things. People want open source tools, and Hadoop is an open source tool. It is very flexible, scalable, cost effective. So these are some of the features which we already saw in the above PPT. And speed and the accuracy. Hadoop gives very fast, very good speed on big data, and the result is also very accurate. And lastly, but the most important part why Hadoop is so popular is we have a cloud support for the Hadoop. So we don't need to purchase the hardware based upon our usage. We will be charged. So we can simply select. We can increase or decrease the number of the node rather than really going and buying. So once we have cloud in place, it becomes very easy for somebody who wants to process and very use big data set in the cloud. Well, components of the Hadoop mostly it is consists of two parts. The hardware part is consists of HDFS, which is Hadoop Distributed File System. It consists of a name node, which is a master node, and various other data nodes. So we have a master slave kind of architecture here. The master is name node, which controls all the slaves, all the data nodes. So any amount of whatever whatever work done by the data node is all submitted to the master, and master is the one which assigns tasks to all the data nodes. It's a master slave kind of architecture hardware, and the application part or the programming part is done by the MapReduce. MapReduce also have a similar architecture. We have a job tracker, which takes up a job from the user, divides the job into a small task, and it divides the small tasks into assigns different tasks to different task tracker. So each data node will have one task tracker, and master node will have one job tracker. Entire job will be divided into a small task and given for the parallel processing. Every system will do the parallel processing, and the result will be given back to the user. So it is master slave kind of architecture where the name node or the admin node has a very vital role to play, and governing all the admin part is done by one node, and the rest of the execution of the task is done at the data node. Workflow is it's very simple workflow. Client interacts. Client is any user who wants to process the data. He will interact with job tracker. Job tracker is the one which is present in the master node, and the job tracker is responsibility of the job tracker to handle the entire work. So job tracker will be dividing the entire job into a small task and assigning it to each task tracker. Now task tracker, which is present in the data node, task tracker will complete its task and assign it back to the master node. So this is the way how the workflow happens, and finally we can get the result. So we can see the result from the menu. If we compare Hadoop, this architecture, with the other system, let's try to have some comparison. The most widely used till now is RDBMS, traditional RDBMS, Oracle database. Now, in terms of data size, if we see in traditional RDBMS, as long as the data size is up to GB, it's always better to go with the traditional RDBMS, because for smaller data byte, MapReduce concept will not be that effective. So if the data volume is anything in terms of petabytes, then it's advisable to go with the MapReduce. Access, interactive and the batch both is supported by the traditional RDBMS. MapReduce, it's mostly suited for the batch processing. Now, the difference between these two is like interactive is something you give the query and immediately you get the result. So this happens in SQL, in Oracle, when we give the query in SQL and we get the result. So this is interactive interactive kind of processing. But in Hadoop, uh, till now, mostly people use it for the batch processing, where you put the entire data set, leave it. You have your big data set. You put it, start your job, and then wait till it's complete. So it will take its own time to complete, and as soon as one batch gets over, you get the result. So this kind of architecture is suitable for the MapReduce. But nowadays, Cloudera comes out with some tool which also makes Hadoop. Uh, it's possible to have interactive processing as well in the Hadoop, but that is very recent. Mostly people use it for the batch processing. Now updates in Oracle tables, read and write many times is very quick, and it is very easy also. But MapReduce, it is more suitable for write once and read many times, because you have bigger data available to you. You put it and then you read it many times, and you can do your analytics and all. So it is mostly suitable for write one and read many times. If you want to update it, then it's not that suitable. So that's the reason. If like it depends upon the kind of what you want to do. If your task need updates many times, then better to go with the RDBMS. Well, from the structure point of view, Oracle RDBMS has static schema, which means we need to have a proper schema defined before doing our data, before storing the data. Schema is nothing but the skeleton of the table structure, the number, data, varchar number. We have to define everything, predefine it, also the size. So if the data, if you say table to have number 10, and the input file has something greater than that, then it will not be put into the Oracle database. It is so accessible. Structure-wise, traditional RDBMS is not that flexible. That's the reason why we need dynamic schema, because there is no need in Hadoop to have a fixed length or a fixed format or a fixed schema. It supports also the unstructured data. So structure-wise, we have more flexibility in the MapReduce way. Data integrity, because traditional hardware, it runs on a very dedicated hardware, on a very dedicated server. So data integrity is high. In MapReduce, it is little low because it runs on a commodity hardware which is very cheap, which is very prone to failure. But by having a proper replication factor, we can ensure that data integrity is also maintained. Scaling wise, we cannot scale the RDBMS according to our need. Now, if today we got a Oracle server of 1 terabyte, data volume is less than that, we cannot make it 1 GB. So that's why in terms of scalability, MapReduce is itself linear. So based upon the data, we can keep on adding the nodes and we can reduce. So we have more flexibility in that area. So this is the comparison of the Hadoop with the other system, and concluding it, when the data volume is very high and you need batch processing, then the best option would be to go with the Hadoop, and it is the one which is standardized by all the companies as a way for big data processing. Nowadays, every company, they have standardized this tool. This is one example how it works. Mostly, let us say if we have a data in one file, which is a very big file, and the Hadoop cluster, once we give this file input to the Hadoop cluster, the entire content will be divided into small chunks of the data, and this small chunks of the data will be acted upon by each data node to be smaller tasks, and our logic which we write, it will be acted upon on each small chunk of the data. The MapReduce is something like map is mapping of the data into a key value pair, and reducing is to get the output of all the keys, combining for a particular key, getting all the outputs, and then we get the final result. So it is like input, sliced off into many different small parts running parallelly, and then finally we are getting the output. So this kind of architecture is not reduced architecture. The entire Hadoop concept is based upon this architecture. Now, some of the Hadoop use cases is like it is used in a lot of industries today, including social network analytics, fraud analysis in terms of energy sector. It is also used telecom company. All the industry we find today use of Hadoop. Wherever we see the data volume to be increasing, uh, anything which goes, which wherever we feel that we are getting a big data problem, then Hadoop is one of the feasible solution for the big data problem. Some examples, some of the recent example in which Hadoop has it has helped to solve the big data problem is recent U.S. election. In the last U.S. election, uh, Obama's campaign team uh, they they gathered because the internet penetration in the US is very high. It's 80% internet penetration in US. So people it's very easy to get the people's sentiment and people analysis. It's very easy to reach out to the people. So Obama's team just 18 months before the scheduled election time, their campaign team they started gathering all sort of possible data from all the possible sources of all the registered voters. So after getting all the data, they uh, they analyzed this. They divided their voters into different categories, like who are in the favor of the Obama, who are not in the favor. How can we reach out to those people? What will be our campaign strategy? Where we need to go for door-to-door campaign, where we can go with the telephone, how can we reach out through the television company, and then who all can sponsor our uh, campaign. So this type of various analytics is made. People reach out to them, and then this is one of the latest examples how big data helped Obama to win the U.S. elections. In terms of data storage also, we have in the automobile sector and also in the railways also, lots of sensors are attached to the devices nowadays, which helps us to monitor the health of the automobile, also how we are driving. So some of the insurance companies nowadays they want to uh, charge their consumer based upon the quality of the driving. So if the quality of the driving is good, then your insurance premium will be less. So for this type of things, you need to have the continuous data of all your consumer, which is all possible from the sensor. So in terms of data storage analytics, it is very useful for the companies. Financial services, banks, and all the insurance companies, they use big data for fraud analysis, and even in IT, people use it for log analysis and all. In healthcare also, uh, there are many hospitals which keep the patient's medical history in their server, and they they send alerts saying you need to have this test done, you need to take this medicine. If the medicine is stock is over, then this is they send alert that okay, you need your next appointment is on this day. So this type of thing is only possible once you have the data and you analyze it properly. In telecom industry, it has a very vital role because since 2006 it is almost mandatory for all the countries to retain the all the consumer and all the call record. Whatever call is made is very important for all this industry to retain it, to save it. They cannot purge this information. So the volume of the data, it increases, and if some report has to be generated on 5 year back, so the it should process a lot of volume of the data. So it's not possible to go with the traditional storage where you get 1 petabyte of the data every year in encrypted storage, and it is something which will continuously go on increasing. So in this type of field, you need Hadoop. Hadoop comes out to be a better solution for this. Energy sector also, it has lot of contribution made. Recently, Vestas is it's a wind power for wind power plant, which before installing any of its plant, it's very important for it to because the output of any wind power plant, it must depend upon the climatic factors. What will be the wind velocity, temperature, precipitation, or in that particular geographic area. So it's very important before the company make billions of dollar investment to have a particular to have good analysis done about the weather prediction. It's very important to store the data of the particular weather information, although stored of all the locations. So it is very important to analyze how the weather of that particular region is varying and how it is expected to vary to predict the weather forecast for the next few years before putting up any plan. And last is the last but very important one is the social media analytics, which we see nowadays very quite often that people use social media for any type of analytics for their product and for anything. So this is some of the examples where big data has a leading role to play. It's already playing, and that's the reason why people are very much interested in this nowadays. So with this, we came to the end of the this is very introductory demo about what is Hadoop and why we need Hadoop. Mostly, what is big data, why all of a sudden this problem came, and how Hadoop turns out to be a solution. So if you have any questions, you can ask me.